Kia ora koutou, welcome to the first video in the NCEA Science 1.1 Demonstrate Understanding of Aspects of Mechanics video series. This standard is more commonly just referred to as mechanics and is the physics part of NCEA Level 1 Science. In this video we will be looking at units and speed. We'll go over those two things, but first we'll just have a look at the NZQA website. Just to look at an overview of what the standard contains. So to find this website, we just need to search NZQA Level 1 Mechanics. We can do this for any standard, and we get this page that comes up. These achievement standards are an overview of the course, which can be a little bit difficult to understand, but if we know where to look, it's actually really helpful. There's a copy of this part of the website in your SciPads as well at the start of each chapter or at the start of each book, depending on which SciPad you have. Included on this page as well are the past exam papers, so we can look at the examination paper for 2019, 2018, all the way back to 2012, 2011 even. There are some exemplar scripts, but what I would recommend when you're looking for answers for these examination papers is to go to the assessment schedule. During this series, we'll spend a bit of time going over past exam papers and looking at the schedules. So for the moment, we'll just look at this achievement standard, the most recent one, outlining what can be covered within Level 1 mechanics. So the first part of it is got a relatively large amount of lingo. We can pretty much skip through 1, 2, 3, 4, even 5. This from part 6, this is where we really start. It starts to get a little bit more specific, and we can really see what the standard involves. So here we've got aspects of mechanics will be limited to a selection from the following. So this is in the exam. This is an external standard, so you'll be assessed for this during an exam at the end of the year. You will have topic tests during the year and school exams during the year as well. But the only time that you actually get the credits for this course is based on your performance in the end of year exam. So in that exam, you won't be tested on anything more than what's written here. So we've got distance, speed, interpretation of distance and speed time graphs, average acceleration and deceleration in the context of everyday experiences such as journeys, sport, getting going, the relationships V equals delta D over delta T, and A equals delta V over delta T, and then so on and so forth for the rest of this. For this video, we're going to start by looking at distance and speed. So what I'm going to do is just copy this part of the screen here, and we'll take that into our whiteboard here. So we're just looking at distance and speed today, and then in future videos we'll look at the interpretation of distance and speed time graphs, and we will gradually get through everything that can be covered in this topic. So we'll start by talking about units. So units, what is the importance in units? If I was to ask you how long is your street, how long is the street that you live on, you would need to give me an answer that would include some form of number. So for example, if I was to say, well, the length of my street is 150. This doesn't hold any value in itself because we don't know it's 150 what. We need to have units to be able to give a value to this number here, or to be able to give some significance to it. So 150, that's not quite. It doesn't give you any information. So what are some? If we were talking about the length of a street, what could this number here? What could this refer to? Well, it could refer to yards. It could refer to, have a think yourself, could refer to miles, could refer to feet, it could be meters, or it could be kilometers, let's say. You might be able to think of some more. So we need to have units to be able to give a value any significance. So this 150 doesn't mean anything until I give you a unit for it. So if I was to say it was 150 kilometers, I mean, that would be an incredible length. My street, you'd probably assume that I live on a highway, for example. Or if I said 150 meters, that's much different, isn't it? That would be just possibly a normal, relatively small suburban street. Or 150 miles, again, that would be incredibly large, 150 yards or 150 feet. We're not quite as familiar with feet and yards, I'm sure, but all of these units would correspond to completely different distances. So units, it's really important that we include units in any answer if we're talking about distance, speed, anything we need to make sure we're including units for it. With science, so if we were to say, if one person gave an answer to say, oh, my street is 150 yards, and somebody else gave an answer to say my street is 150 meters, it's not very useful to be using lots of different types of units when we're trying to compare things. So what we need to do in science is decide on particular units that we are going to be using across the board so that we can compare values together easily. So the units that we use in science are always going to be for distance, they're going to be meters. For time, we will see seconds. For mass, we'll use kilograms, just for example. So here's 3 examples here, and we'll come across some more as we go through this topic. So the first 2 important units that we need to know are meters and seconds that we use. An example of why it's really important to use the right units or use the same units is this Mars Climate Orbiter, which was launched in 1998, went for 9 months, 11 days, 5 hours, 14 minutes, and 9 seconds. So it was designed to be able to orbit Mars and then be used as a communication device for a rover that they had that was going to be going around on Mars. So this was designed to study Mars from orbit and serve as a communications relay for the Mars Polar Lander and deep space probes. The mission was unsuccessful due to a navigation error caused by a failure to translate English units to metric. So they had used, they were sending units in pound seconds and not the standard Newton seconds. So that caused $150 million of damage just by not using the correct units. So we won't be able to cause quite so much damage if we don't use the correct units for our topic, but it might cause you to go from a merit to an achieved, for example. So units are really important in the wider world. In terms of our standard, we need to be using units to be able to get as good a grade as we can. So those are the importance of units. We will start looking at speed. So what actually is speed? A common situation that we would think about speed would be if we were in a car and we can look down at the speedometer in the car and that will tell us the speed that we are traveling. So the units that we are familiar with for speed in New Zealand are kilometers per hour. So if we were in a car driving on State Highway 1 and we looked at the speedometer and it told us that we were going 100 kilometers per hour, or commonly we would just refer to that as 100k. What does that actually mean in terms of the car that we're in? So 100, let's break that down. So we've got 100 kilometers per hour. You'll often see it, this is how you would see it written on the speedometer in the car. What does this mean in terms of the car? So we would have, if we drew just a line here, let's say this is a section of road. So this is 100 kilometers, we'll say, 100 kilometers. So the speed will tell us how long it's going to take us in the car to travel this distance. So we know that we're going 100 kilometers per hour. So it would take us, if we were driving along this road, it would take us 1 hour to get from the start, from 0 meters, to 100 kilometers. It would take us 1 hour. 1 hour to go those 100 kilometers. So the speed there is 100 kilometers per hour. What speed would we be going if we went 50 kilometers, for example? So we went half the distance, 50 kilometers in 1 hour. How would we know what the speed is there? Well, it makes sense just by saying the words out, the kilometers per hour. So in 1 hour, if we traveled 50 kilometers, that would mean that we were going 50 kilometers per hour. So that's nice and relatively easy. So in 1 hour, this would be 50 kilometers per hour. What gets a little bit trickier is if we don't work in those whole numbers of hours. Let's finish this off. So we use that slash. That slash means divided by, or when we're talking about it, per. So kilometers per hour, we need to use that slash, that divided by sign there. So if we were going 50 kilometers, and let's say it took us 2 hours, what would our speed be if we went 50 kilometers in 2 hours? Well, we would have to look at this. So in 1 hour then, we would travel half. So if this took us, after 1 hour, we would be halfway through. So the speed in this case would be that we were going 25 kilometers per hour. So every hour we went 25 kilometers, and then after 2 hours we would have made it to those 50 kilometers. So in this case, we're traveling at, I'll just get the text here because it's easier. So we'd be going 25 kilometers per hour. So that's not too bad either if we're using whole numbers there. So 1 kilometer per hour, we're going, if we travel 50 kilometers, 50 kilometers an hour. In 2 hours, if we travel 50 kilometers, we're going 25 kilometers per hour. What if it took us 2.5 hours to travel those 50 kilometers? How is it that we're actually working this out? Are we just doing it intuitively, or is there some sort of formula that we're using? So if it took us 2 hours, 2.5 hours to go, so we traveled along the road, which is 50 kilometers. How do we work out what the speed actually is for us to travel that distance? 50 kilometers. So what we need to do, what we're doing here, and we might not realize it, is that we're going the distance. So we're taking the distance and we're dividing it by the time. So in this case, we took 50 kilometers and we divided it by 2. So we got 25 kilometers per hour. So for this one, we have got 50 kilometers and we divide that by 2.5. So to find out the speed of something, what we need to do is find the distance that we've traveled and divide it by the time that it's taken to travel that distance. So that's how we work out the speed that something is traveling. That's what the definition of speed actually is the speed is the distance traveled per time. So speed is the distance traveled per time. I'll just write you can give this a go if you want here. So you'd have to go 50 divided by 2.5, and that equals 20. So in this case, we'd be going 20 kilometers per hour. So if speed is the distance traveled per time, we can actually write that as a formula. So traveled per, like I was saying before, we had that slash or that divided by, that is the same as saying per. So we could say speed equals distance divided by time, like that. Speed equals distance divided by time. So this is the first formula that we've been given. This is the first formula that we will need to know. In the exam, we are actually given these formulas. So we'll have a look at what we get in the exam. Here it is here. So this is last year's exam. At the start of your exam paper, you get given these here. And notice how they're not quite written the same as what I've done here. You don't see speed equals distance divided by time. What we see is V equals change in D over change in T. A equals change in V over change in T, etc. So there's different symbols that are used for each of the formulas. So we're going to need to remember what these letters represent. So we need to know what the units are and represent. So for example, M is meters, and we're going to need to know what symbol is given to each each variable. So for example, d is distance. And we'll have a look at how to break this down now. So I'll bring this into our screen. So speed is for this course, speed is used interchangeably with velocity. So velocity will be something that you learn more about if you continue doing physics through to level 2 and level 3. But for this course, we just use speed and velocity interchangeably, so you can think of them as the same thing. But when we come to the formulas, we see V and not S or anything like that. So V equals velocity, or you can think of it as speed. So this speed equals distance divided by time. This is actually given to us in the exam. It's given to us with this formula here. So V equals that triangle D over triangle T. The triangle is the symbol for delta. In this case, it just means change in. So triangle means change in. So the change in distance, for example, here, that's 50 kilometers. So if we were to say that we started at this point here, which was 0 kilometers, and we finished at the final point, which was 50 kilometers, the change is 50 kilometers. So often the change in distance is just the same as it's effectively the total distance traveled. So the change in distance here would be 50 minus 0, so still 50 kilometers. And it's the same with the time, the change in time. We've got 2.5 hours, so by the time we've got to 50 kilometers, 2.5 hours has elapsed, but at the starting point is 0. So the change in distance here would be 50 kilometers, and the change in time would be 2.5 hours. So it's good to know we've got these formulas that are going to be given to us in the end of year exam. We just need to remember what these symbols mean. The other thing that we need to remember is if you think back to when I was talking about units, I said that when we're talking about distance, we use meters, and when we're talking about time, we use seconds. So colloquially, when we're talking about the speed we go in a car, we always use kilometers per hours because that's just a more relevant way of talking about it. When we're talking about speed with science and with this topic, we need to talk about it in terms of meters and seconds. So you won't ever see, for this course, you won't see something kilometers per hour. It'll always be meters per second. So an example could be if we were traveling, let's say we traveled 15 meters, and we did that in, 15 meters. As I was saying, it's really important to use those units. Let's say we did that in 3 seconds. So how would we be able to work out the speed that we were going if we took 3 seconds to travel 15 meters? So we need to use this formula here. The speed equals the change in distance divided by the change in time. So we've got 0 meters at the start, 15 at the end. So it's 15 meters in 3 seconds. So we go distance divided by time. So it's speed or velocity equals the distance, 15, divided by the time, which is 3. And what we're going to get is 15 divided by 3 is 5. So we get 5, and then remember we need to write the units. So the units are similar to how you would write kilometers per hour. You can go meters per second. So for every second we travel 5 meters. So after 1 second, the distance would be 5 meters. After 2 seconds, the distance would be 10 meters. And then after 3 seconds, the distance is 15 meters. So you'll often see units written like this if it's meters per second. You might also see meters per second, and actually more commonly, you will see it written as ms to the power of -1. So that's meters times seconds to the power of -1. The reason that we do this is just to make it easier to write. But if you go to the power, if you take any number and go to the power of -1, the answer that you get will be the same as going 1 divided by that number. So writing this, ms to the power of -1, is the same as saying meters divided by seconds. And that's the same as going meters per second like this. So this is another thing to get used to, is that you might see the units written seconds to the power of -1. You won't see them written like this, but this is just to show that it's meters divided by second, or you could see meters with a slash per second like that. So that's it for this video. I would give this some practice if you haven't done this before. So we've covered units, we've looked at speed, and we've worked out the formula for speed and the correct units that we would use when we're talking about speed. So thanks for watching this video. Like and subscribe for more videos, and look forward to seeing you next time with the next Level 1 Science Mechanics video.